right, we are back with one that I did not go over before because I did not have a question like this originally. When I went back and redid it for more accuracy, I ended up with a question like this, where there are two sets of parentheses within a larger set of parentheses that has an exponent outside of it. This was the same question somebody had for me before, so I wanted to make sure I went over it, even though it's kind of the same as some of the others. So, in this case, you have a product rule within your entire chain rule. So, in order to solve that, you have to figure out what all of your pieces are. And this is a little bit complicated because it's not the same as it would be normally. Not quite, anyway. So, in order to solve this one, and this one has a lot of writing, in order to solve this one, you have to take the derivative of the entire thing, which is this right here, just like we normally do with our chain rule. But then you have to go back and find the derivative of everything else, which is the second part. Okay? So, I just go ahead and do this first part, since it is fairly simple. It's just moving the exponent to the front, leaving everything that's in parentheses, and then subtracting 1 from your original exponent. So that part I don't really write out anywhere else. For this second part, you do have to find your derivative of each part, which is this big old square right here. You do have to find the individual parts. So your first term is your f, your second term is your g, and then your derivative and your derivative. So I've written those in the box. You would do the same thing. I like to put those on the side to help me because it's just easier that way. Okay, so then I don't keep rewriting this part on the left. There's really no point when it's just going to get brought down. You're not going to do anything else to that until you basically get to the very end. So then I just focus on my derivative of the second part, which I wrote down in the colors that I used originally, and then you just distribute your numbers out. So in this case, it was easier to say, 40 times 5 and then 40 times 10, multiply all that out, do the same thing on this other side, and then combine your terms, blah, blah, blah. And then I'm not very good at determining greatest common factor because I haven't done that in 8 plus years. So I like to take it a little at a time. So I will do my variables first because obviously I can tell that the maximum I can take out is an x squared. So I'll pull that out and remove it and then go back in and pull what I can tell is going to be able to be taken out, which in this case is obviously a 5. Everything here is divisible by 5, and so that's what this over here shows that I've underlined. I pulled an x squared out here, I pulled a 5 out the next time, and then that brings me this, which obviously cannot be reduced any further. So then I underline my my terms that have been pulled out. So a 4 from over here at the beginning, and an x squared and a 5. Obviously 4 times 5 is 20, and then you add your x squared to that and you get 20x squared. You bring down what was left of this term over here at the top. That I said you don't need to rewrite a bunch of times. Just remember to bring it down. So I bring that down and then multiply it times what we found here at the bottom, the 70x to the fourth plus 80x plus 3. And that was what I wanted for the answer. That's it. That's all I wanted. So it was a lot simpler than it looked. So I hope that helps somebody.